For millions of years, the most dangerous direction was not in front of us, it was above us. Long before people feared wolves, lions, or saber-toothed cats, something else had already mastered the art of hunting our ancestors from the sky. The evidence has existed for nearly a century, preserved in ancient bone, yet its true meaning remained hidden for decades. One living eagle in Africa is capable of carrying off primates weighing up to 4 times its own body weight. In some forests, primates make up more than 80% of its diet. It is the only eagle on Earth with that level of specialization, and its closest prehistoric relative may hold the answer to one of the oldest mysteries in human origins. That mystery begins with a skull nearly 3 million years old. Beneath its eye sockets are two unusual puncture wounds that puzzled generations of scientists. Today, those marks are recognized as matching a highly specific method still used by large eagles to kill prey too large to overpower in any other way. Thousands of kilometers away, another giant raptor once ruled the skies. With a wingspan of nearly 3 meters, which is about 10 feet, and talons comparable to a tiger's claws, it survived long enough to encounter people. Those encounters became part of local tradition. Centuries later, its skeleton revealed something remarkable. The bird was physically capable of killing an adult human. Two predators, two continents, nearly 3 million years apart, yet both point toward the same forgotten chapter of our history. We often think of ourselves as the species that conquered nature, but for most of our evolutionary story, there were moments when something high above looked down and saw us as prey. In this story, we'll follow the fossil evidence, the forensic investigation, and the remarkable scientific discoveries that transformed a 70-year-old mystery into one of the most compelling chapters in human evolution. If this is your kind of thing, hit like and subscribe. It costs nothing and it keeps this channel going. And drop a comment below. Are you watching this winding down for the night or watching this during your active day? Let's travel back to the skies above ancient Africa, across southern Africa, between about 3 million years ago and 2.5 million years ago. Broad stretches of grassland blended into scattered woodland beneath an open sky. Trees gathered in patches instead of continuous forest, leaving long intervals of exposed ground between them. Every journey across that landscape unfolded beneath a ceiling, with few places to disappear from view, where movement overhead carried consequences as real as anything waiting among the grasses. Living there was Australopithecus africanus, an early member of the human family tree. It walked upright on 2 legs, freeing its hands while traveling across the landscape, although it still climbed with ease whenever branches offered safety or food. Adults remained modest in size compared with later humans, and the youngest members of each group were smaller still. Juveniles weighed about 9 to 12 kilograms, which is about 20 to 26 pounds. That placed them within the same weight range regularly hunted by large African birds of prey living today. A fact that seems ordinary at first becomes essential once the evidence begins to gather. Life for these early relatives depended on awareness in every direction. Food, water, and shelter demanded daily movement through changing terrain, where visibility shifted from open grass to clusters of trees and back again. A youngster separated by only a brief distance could appear very different to a predator than an adult standing nearby. Size alone shaped opportunity, and natural selection has always favored hunters able to recognize it without hesitation. Before following the fossils themselves, one scientific tool deserves a place in the story. It is called taphonomy, the forensic study of everything that happens to an organism after death, including the clues preserved on bone. Every predator leaves a distinctive record. A leopard grips with powerful jaws that score and crush in recognizable ways. A hyena breaks bone through immense bite force, producing another pattern entirely. Large birds of prey create marks unlike either mammal. Talons press into particular parts of the skeleton, while the beak cuts with its own characteristic shape. When those traces survive the passage of immense spans of time, they can be compared with carefully documented collections from living animals and matched with striking precision. That approach transformed ancient bones into evidence that could be examined almost like a modern forensic investigation. Instead of relying on broad assumptions about which predator lived nearby, researchers could compare tiny wounds, fractures, and punctures against known examples collected from contemporary kill sites. Bone became a record preserving actions that lasted only moments, then remained unchanged across millions of years. One discovery would eventually place every one of those methods into a single remarkable investigation. During 1924, workers blasting limestone in South Africa uncovered the fossilized skull of a child unlike any previously recognized. It would become one of the most significant fossils in the study of human origins. For the next 70 years, the cause of death remained officially unknown, even though the answer had rested on the bone from the beginning, waiting for someone who knew how to read its enduring marks. Dust drifted through the limestone quarry at Taung during the year 1924, where workers broke apart hardened deposits formed from the remains of a cave that had collapsed long before human memory. Inside that cemented mixture of stone, soil, and fossil fragments, one small skull emerged from the rock. It belonged to a child, preserved with extraordinary completeness after nearly 3 million years, carried through time inside a natural archive no one expected to open that day. The specimen soon reached anatomist Raymond Dart at the University of the Witwatersrand. As he carefully removed the surrounding rock, familiar features gave way to something entirely unfamiliar. The face carried an unmistakable blend of ape and human characteristics. Its brain cavity exceeded that of any ape with a similar body size, while the opening where the spinal column entered the skull rested underneath instead of behind, showing that its owner had walked upright. Dart understood that he was examining a member of the human family unlike any formerly recognized before. His conclusion challenged accepted ideas about where humanity began. During 1925, he introduced the fossil to the scientific world under the name Australopithecus africanus, meaning southern ape of Africa. The announcement appeared in the journal Nature and immediately stirred intense disagreement among researchers who still believed Europe or Asia held the earliest chapters of human origins. The small skull from South Africa became the center of one of the most enduring debates in paleoanthropology, while its youthful owner came to be known as the Taung Child. As attention focused on its importance, another feature remained difficult to understand. Near the base of both eye sockets were two neat punctures, unlike the crushing damage expected from familiar mammalian predators. Across the crown rested additional marks whose arrangement resisted every straightforward explanation. They were visible from the beginning, recorded in plain sight on one of the world's most significant fossils, yet they matched no accepted interpretation available at the time. Dart examined those injuries with the same care he devoted to every other part of the specimen. He described them faithfully, acknowledged that they defied explanation, and continued his work. There was little else he could do. Without modern collections of comparable predator damage, the markings remained isolated observations instead of meaningful evidence. They entered museum records, scientific papers, and careful illustrations, preserved alongside every other detail of the remarkable skull. Decades passed as generation after generation of researchers returned to the Taung Child. Advances in dating methods, anatomy, and human evolution transformed many parts of the discussion, while the unusual damage remained almost untouched. Thousands of experienced eyes looked directly at the same punctures, the same fractures, and the same delicate impressions. Each examination added another layer of careful observation, although none supplied the missing interpretation. The fossil never concealed its history. Every mark survived exactly where it had formed millions of years earlier, wading through cabinets, laboratories, and countless studies. The challenge rested in recognizing that the clues belonged together, forming a pattern no one had yet learned to read. The record endured with remarkable patience, preserving a final moment until scientific understanding eventually caught up with the evidence already resting on the bone. Ideas can leave marks almost as lasting as fossils. Once the Taung Child entered scientific history, attention gradually turned from describing the skull to explaining the injuries it carried. Raymond Dart believed those unusual wounds reflected conflict within the human family itself. From the evidence available to him, he concluded that another early hominin had caused the damage, placing violence at the center of one of humanity's oldest stories. That interpretation expanded into a much broader proposal that became known as the killer ape hypothesis. Dart argued that aggression, the use of simple tools as weapons, and repeated attacks against members of the same species shaped the earliest stages of human evolution. Competition and conflict, in his view, provided the driving force behind the growth of intelligence and the development of social behavior. The Taung Child became one piece within a much larger picture describing humanity's distant past. The idea reached far beyond the study of fossils. During the middle decades of the 20th century, it influenced books, documentaries, public discussions, and popular culture. Writers exploring the origins of warfare often pointed back toward Dart's proposal, seeing deep evolutionary roots beneath organized violence. The image proved memorable because it seemed to offer an explanation for many aspects of human history, connecting prehistoric life with conflicts that continued into the modern world. While the theory gained influence, another collection of evidence remained patiently available at Taung itself. The surrounding deposits contained skulls and bones from many different animals gathered over an immense span of time. Each fossil carried information about how it had reached the site. Viewed together, those remains formed a pattern that deserved the same careful attention given to the famous child discovered among them. Archaeologists had already learned what genuine hominin butchery sites usually looked like. Stone tools leave narrow cut marks across bone surfaces where muscles are removed. Bones fractured to extract nutritious marrow break in recognizable ways, often producing fresh splintering unlike damage caused after burial. Carcasses tend to be processed selectively, with particular body parts transported or discarded according to practical needs. Across many prehistoric sites, those signatures appear again and again with dependable consistency. Tong presented something very different. The collection included numerous small primates, birds, and lizards, accompanied by an absence of the expected traces from repeated hominin processing. Cut marks were missing. Characteristic breakage patterns did not appear. The assortment looked less like the remains of meals prepared with tools and more like animals gathered by a predator with very different habits. Each newly examined specimen quietly strengthened that impression, even though the broader interpretation remained unchanged. Researchers familiar with living ecosystems recognized another possibility. Beneath the nesting places of large birds of prey, Similar collections often accumulate through repeated hunting over many breeding seasons. Small mammals, climbing primates, reptiles, and birds commonly appear together because they belong to the regular diet of powerful raptors. The resemblance grew more striking as additional observations entered the scientific record. For many years, those observations remained scattered instead of unified. The killer ape hypothesis continued to stand, supported more by its influence than by the physical arrangement of the fossils themselves. Gradually, the bones at Taung began to suggest a different history, one that rested on comparison instead of assumption, allowing the evidence to speak with increasing clarity as understanding slowly caught up with what had been preserved all along. Some discoveries begin with years of planning. Others arrive in a moment so ordinary that their importance remains invisible until much later. During the year 1994, paleoanthropologist Lee Berger was carrying out fieldwork in South Africa when an event unfolded before him with almost no warning. High above the landscape, a crowned eagle launched from its perch, descended with astonishing precision, seized a monkey using both feet, and rose again with its prey before the surrounding forest had fully reacted. Berger had witnessed a hunting sequence that few researchers ever observed directly. The attack lasted only moments, yet every movement followed a pattern refined through countless generations. There was no prolonged chase across the trees. The eagle relied on timing, momentum, and overwhelming grip strength, ending the encounter almost as quickly as it had begun. What remained in Berger's memory was not only the speed of the strike, but the opportunity it presented. He chose to follow the predator. The search led him to the eagle's nesting site, where years of successful hunts had left a growing collection of bones scattered across the ground. Among those remains were monkey skulls, preserved well enough to retain delicate traces of how each animal had died. Berger examined them carefully, noticing injuries unlike any formally described in the scientific literature available at the time. Near the base of the eye sockets appeared distinctive puncture marks. The edges of the orbital bone carried rough cuts. Across the top of several skulls rested small sections where the bone had been pressed inward by tremendous force. Each specimen displayed the same arrangement, with remarkable consistency. The injuries were not random damage produced after death. They occupied similar locations across multiple skulls, suggesting that every strike followed an established hunting technique. The eagle's talons and beak left their own recognizable signature, one repeated often enough to become visible through comparison. Berger realized he was looking at something worth preserving, even though its broader significance had not yet become apparent. He photographed the skulls from multiple angles, recorded careful notes, and documented every observable feature before leaving the site. Those records joined the growing collection of field observations accumulated during his research. They represented valuable information, although they lacked the framework needed to answer a larger question. At that moment, they remained exactly what they appeared to be: detailed documentation of modern predation by a living raptor. Years passed, and those photographs rested among countless other research materials collected throughout Berger's career. Scientific work often advances in this gradual way, with observations waiting for new discoveries to reveal their meaning. Valuable evidence sometimes arrives long before the concepts capable of interpreting it. Until those ideas emerge, the information remains complete yet incomplete, patiently occupying its place within the scientific record. The memory of that crowned eagle never disappeared, even as other projects demanded attention. Neither did the unusual damage preserved on the monkey skulls gathered beneath its nest. More than a decade would pass before another study offered the comparison Berger had been missing. When that connection finally appeared, the photographs from 1994 became something entirely different. They transformed from an interesting field observation into the missing reference that allowed one of the oldest mysteries in human origins to be viewed through an entirely new lens, revealing that the living world had preserved the same story all along. Scientific understanding often advances through careful comparison instead of dramatic revelation. During the year 1995, Lee Berger and his colleague Ron Clark assembled years of observations into a formal proposal that challenged one of the most familiar interpretations in human origins research. Their conclusion departed sharply from the accepted view. The Taung Child, they argued, had not become part of the fossil record through violence inflicted by another early human relative. The evidence pointed toward a large bird of prey. Their publication rested on patterns collected from the site itself. Every bone discovered alongside the famous skull became part of a larger ecological picture. Small primates appeared repeatedly. Birds were well represented. Lizards also occurred throughout the deposit. Viewed together, the collection resembled the remains commonly found beneath nesting sites occupied by powerful African eagles. The arrangement did not resemble the characteristic record left behind by hominins processing food, nor did it resemble the feeding traces expected from large mammalian carnivores. The comparison extended beyond the kinds of animals present. Active eagle nests often accumulate prey across many seasons, gradually building a mixed collection of skeletons representing the species hunted most frequently. Such deposits contain a broad assortment of relatively small animals gathered from the surrounding landscape. Taung displayed the same general composition. The similarities emerged through careful examination of the entire assemblage instead of relying on any single fossil in isolation. Berger and Clark presented their findings with restraint, supporting each point through comparisons drawn from living ecosystems, fossil evidence, and established principles of taphonomy. Their work avoided dramatic claims, allowing the preserved bones to guide the interpretation. Every observation strengthened the possibility that the site recorded the feeding activity of a large raptor across an extended period of time. The response from much of the scientific community arrived swiftly, and it was largely dismissive. Many researchers regarded the proposal as incompatible with what was then believed about the physical limits of eagles. One objection overshadowed every other part of the discussion. Juvenile Australopithecus africanus individuals weighed approximately 9 to 12 kilograms, which is about 20 to 26 pounds. That body mass appeared too great for any known eagle to lift and transport. If the bird could not carry the child, the hypothesis seemed impossible. At first glance, the criticism appeared convincing. Large birds of prey were widely imagined as predators, limited to comparatively light animals. Estimates of carrying ability focused almost entirely on sustained flight, while supporting the complete weight of freshly killed prey. Within that framework, the proposed explanation struggled to gain acceptance, and many researchers considered the discussion effectively settled before additional evidence could accumulate. Outside the debate, field biologists continued documenting crowned eagles across forests and woodlands throughout sub-Saharan Africa. Their work centered on hunting behavior, prey selection, nesting ecology, and the daily lives of living birds instead of fossil mysteries. Each season produced new observations gathered directly from nature, carefully recorded without any expectation that they would influence one of paleoanthropology's oldest controversies. Those independent studies gradually assembled a picture that differed from long held assumptions. The accumulating evidence came from living predators carrying out familiar behaviors across the same continent where the Taung Child once lived. Piece by piece, the practical limits assigned to large African eagles began to shift, shaped by observation instead of expectation, allowing the natural world to speak with increasing clarity through its own enduring record. Evidence accumulated gradually across forests, separated by hundreds of kilometers, which is about 621 miles. Individual observations seemed modest when viewed alone, yet together they reshaped scientific understanding of one of Africa's most powerful aerial predators. Throughout the closing years of the 1990s and into the early years of the following decade, field researchers repeatedly documented crowned eagles, taking prey much larger than earlier estimates had considered possible. The records came from long-term studies of nesting territories, direct observations, recovered prey remains, and careful monitoring of hunting behavior. Again and again, crowned eagles proved capable of killing animals that exceeded their own body weight several times over. Among the most striking examples were bushbuck calves weighing as much as 30 kilograms, which is about 66 pounds. Such prey approached nearly 8 times the eagle's own mass, extending far beyond the limits many researchers had previously accepted. These observations demanded a closer examination of how the birds actually hunted. Earlier assumptions had rested on a simple image of an eagle lifting an entire animal into sustained flight immediately after making a kill. Nature proved far more flexible. Crowned eagles often attacked from concealed perches, bringing prey to the ground with a forceful strike before maintaining a firm grip until the struggle ended. The hunt did not conclude the instant the animal stopped moving, it entered another stage. Large prey was frequently consumed where it fell. The eagle fed first upon the most nutritious tissues, reducing the remaining weight before attempting transport. When conditions allowed, portions of the carcass were carried separately to the nest across multiple journeys. Sometimes only selected body parts were moved, while the remainder stayed at the original location. The behavior varied according to terrain, distance, surrounding vegetation, and the size of the prey itself. None of those strategies required lifting the complete animal through a long, uninterrupted flight. This practical sequence transformed the debate surrounding the Taung Child. The central objection had depended almost entirely upon an assumption about carrying capacity. Once researchers understood that transport could occur in stages, the earlier calculation no longer determined what was biologically possible. The question shifted away from whether an eagle could lift every kilogram at once and toward whether its documented hunting behavior matched the circumstances suggested by the fossil evidence. Field observations continued reinforcing the same conclusion. Living crowned eagles displayed flexibility, patience, and repeated use of strategies that reduced the challenge of handling exceptionally large prey. Their success depended less upon raw lifting strength than upon careful use of the landscape, secure footing, and repeated visits between feeding sites and nests. Every documented hunt expanded the growing body of evidence describing what these birds truly accomplished outside controlled assumptions. As those reports accumulated across sub-Saharan Africa, confidence in the original weight objection steadily diminished. Independent research groups, working in different regions, reached compatible conclusions because they observed the same predator carrying out the same behaviors under natural conditions. The consistency mattered as much as any individual record. Science rarely changes through a single dramatic observation. It advances when separate lines of evidence converge until earlier expectations no longer fit the reality being measured. With the practical limits now redefined, attention returned to the fossil that had inspired the debate. The question no longer centered on physical possibility. Living eagles had already demonstrated that. The remaining task was far more precise, asking whether the marks preserved on one small skull carried the unmistakable signature of the hunting methods now documented in the forests of modern Africa. The turning point arrived through careful organization instead of a new fossil discovery. During the year 2006, a research team from Ohio State University, led by Scott McGraw, published a comparative study that gathered years of scattered observations into a single forensic framework. Individual field researchers had encountered the same forms of damage many times while examining prey left by crowned eagles, yet those recurring patterns had never been systematically described, classified, and compared with fossils from the distant past. McGraw and his colleagues approached the evidence with remarkable precision. They examined skulls belonging to modern primates, taken by large African eagles, documenting every consistent injury left behind during the attack and feeding process. Their goal extended beyond describing isolated wounds. They sought a repeatable set of diagnostic markers that could distinguish eagle predation from every other known source of skeletal damage. Once identified, those markers could be applied to fossil collections with the same careful standards used in forensic investigations. Several features appeared repeatedly. One involved shallow sections of bone pressed inward across the crown of the skull, produced when powerful talons struck with tremendous force during the initial attack. Another consisted of distinctive openings along the sides of the skull, shaped by the hooked beak as it worked through the bone during feeding. Each mark occupied predictable locations and appeared consistently enough to establish a recognizable pattern instead of random variation. The most revealing feature lay around the eye sockets. McGraw documented puncture marks accompanied by irregular cuts at the base of both orbital cavities. These injuries formed when an eagle inserted its talons into the openings surrounding the eyes to gain access to the brain. For prey too large to crush with direct pressure alone, the orbital cavity provided a natural pathway through the skull. The resulting wounds displayed a distinctive combination of placement and shape that differed from injuries produced by mammals or by natural processes after death. Together, these characteristics created something researchers had never possessed before. They were no longer examining isolated marks that depended upon individual interpretation. They now held a comparative reference built from living examples, one capable of testing fossil evidence through measurable similarities. The scattered observations collected across decades had become a coherent forensic language. When Lee Berger read the publication, recognition arrived almost immediately. The descriptions before him matched details preserved in his own field notes from the crowned eagle nest he had examined during the year 1994. The punctures surrounding the eye sockets, the irregular cuts, and the compressed areas across the top of the skull all echoed injuries he had photographed years earlier without fully understanding their importance. Those forgotten images suddenly acquired an entirely different meaning. Scientific progress often depends upon moments when separate discoveries unexpectedly align. Berger had observed the evidence directly in living ecosystems. McGraw's team had provided the structured framework needed to interpret it. Neither achievement alone completed the puzzle. Together they formed a bridge connecting modern predation with a fossil that had resisted explanation for generations. The connection left little room for hesitation. Berger returned to the Taung Child with the published criteria fresh in his mind, prepared to examine one of the most famous fossils in human origins through a lens that had not existed when Raymond Dart first held it. The skull itself had remained unchanged across every passing decade. Only the knowledge brought to its surface had evolved enough to reveal what the preserved bone had recorded from the very beginning. Knowledge can transform an object without altering a single fragment of it. Carrying the comparative framework developed by Scott McGraw's team, Lee Berger returned once more to the Taung Child. The skull resting before him had remained physically unchanged through every previous examination. This time, however, the evidence would be viewed through a carefully established set of diagnostic features instead of isolated observations. Berger began a deliberate inspection, comparing each region of the fossil against the documented signatures of eagle predation. Across the crown, he identified the compressed flaps of bone expected from the impact of powerful talons. Along the sides appeared the characteristic openings produced by repeated beak activity. Every feature corresponded closely with the injuries catalogued from modern primate remains collected beneath crowned eagle nests. The fossil was no longer presenting scattered mysteries. It displayed a coherent pattern extending across the entire skull. His attention then settled upon the eye sockets, the region that had puzzled generations of researchers. At the base of each orbital cavity lay the same puncture marks and irregular cuts described in McGraw's comparative study. They appeared on both sides with striking symmetry, occupying precisely the locations expected if a large eagle had driven its talons through the openings surrounding the eyes while feeding. Those injuries represented the most distinctive marker in the entire forensic framework, and they matched the published descriptions with extraordinary precision. Even such a powerful correspondence required another careful test. Fossils often undergo preparation after excavation, with surrounding rock removed through delicate mechanical work performed by skilled technicians. Berger needed to eliminate every possibility that the unusual marks had been introduced accidentally during cleaning or later handling. A conclusion carrying such importance demanded evidence extending beyond the original specimen alone. That search led him to a remarkable historical resource. Shortly after the discovery of the Taung Child, during the year 1925, researchers had created a detailed cast of the skull. Produced within a year of excavation, it preserved the fossil's condition before decades of study, transport, and repeated examination. Berger obtained the cast and compared it directly with the original specimen, focusing especially on the areas surrounding the eye sockets and the top of the skull. The comparison produced an unmistakable result. Every significant injury appeared on the early cast exactly where it existed on the fossil itself. The punctures remained present. The compressed bone across the crown remained unchanged. The distinctive cuts along the skull matched as well. Those features had not emerged during preparation, restoration, or museum handling. They had accompanied the fossil from the moment quarry workers first exposed it within the limestone deposits. For approximately 80 years, they had remained fully visible on one of the most intensively studied fossils in African paleoanthropology. Berger later described the moment of recognition with memorable honesty. Looking directly into the eye sockets, he realized the marks aligned perfectly with the diagnostic pattern established from living crowned eagles. He recalled that he almost dropped the skull as the full significance settled into place. The fossil had never concealed its final chapter. Scientific understanding had finally grown detailed enough to recognize it. With that final verification complete, the investigation reached a level of confidence it had never possessed before. Independent observations from living predators, comparative forensic research, historical records, and the fossil itself now converged into a single explanation, allowing the last moments of one young member of the human family to emerge from evidence preserved across nearly 3 million years. A sequence lasting only a brief span of time can leave traces that endure across millions of years. Once every line of evidence had been assembled, researchers could reconstruct the final moments of the Taung Child with an unusual degree of confidence. The account did not emerge from imagination or dramatic interpretation. It arose from fossil damage, comparative anatomy, documented behavior of living crowned eagles, and the arrangement of bones preserved within the ancient deposit. The encounter most likely began without prolonged pursuit. Modern crowned eagles hunt from concealed perches, remaining motionless until an opportunity appears below. When the moment arrives, they descend with extraordinary speed, extending both feet before impact. Their talons strike the head or upper body almost simultaneously, gripping with tremendous force. Field studies have repeatedly documented this hunting method against living primates, making it the closest behavioral model available for understanding the injuries preserved on the Taung Child. The initial strike would have unfolded so rapidly that nearby members of the group had little opportunity to respond. Observations of modern primates reveal a consistent pattern after a successful crowned eagle attack. Calls spread through the surrounding trees, individuals scatter, and surviving animals move away from the immediate location instead of confronting the predator directly. This behavior reduces additional losses, although it also leaves the captured victim behind once escape becomes the safest option for the remaining group. After the disturbance faded, the eagle could return to feed without sustained interference. Comparative studies show that large prey often cannot be opened by crushing the skull alone. Instead, the bird uses its talons and hooked beak around the orbital cavities, creating access to the brain through the openings surrounding the eyes. That feeding technique produces the distinctive punctures and irregular cuts identified on modern primate remains and later recognized on the Taung Child itself. The compressed areas across the top of the skull, the beak marks, and the paired injuries near both eye sockets all fit within that established pattern. Feeding likely continued at the original location until the carcass became lighter and easier to handle. Living crowned eagles regularly transport prey in stages when dealing with larger animals, carrying selected portions or returning repeatedly between feeding sites and the nest. The reconstructed sequence suggests that the skull and remaining skeletal elements eventually reach the nesting area through this well-documented behavior. Becoming part of the growing accumulation of prey remains surrounding the nest. The passage of immense spans of time completed the final stage of the process. The nest itself disappeared through natural decay, while scattered bones gradually slipped into the cave system below. Sediment, fragments of limestone, and mineral-rich water slowly surrounded them, creating the hardened rock known as breccia. Within that protective matrix, the bones remained undisturbed while landscapes shifted, climates changed, and countless generations passed across southern Africa. Nearly 3 million years later, quarry workers shattered part of that ancient deposit with explosive charges, exposing the small skull once again. Raymond Dart lifted a fossil whose final chapter had accompanied it since the day the child died. Every puncture, fracture, and impression remained exactly where it had formed. The evidence required no alteration across those immense stretches of time. Only the ability to recognize its meaning arrived much later, allowing preserved bone to speak with remarkable clarity after wading through ages almost beyond imagination. Across the forests of sub-Saharan Africa, the hunter still exists. It has crossed countless generations with remarkably little change, carrying the same body plan that once shaped a moment preserved within the Taung Child. Its scientific name is Stephanoatus coronatus, commonly known as the crowned eagle. Unlike the predators known only through fossils, this one continues its daily routine beneath living branches, offering researchers an opportunity to observe behavior that reaches deep into humanity's distant past. At first glance, the bird does not appear extraordinary beside many larger eagles. An adult typically weighs between 3.4 and 4.7 kilograms, which is about 7.5 to 10.4 pounds. Its wings can spread as far as 1.8 meters, which is about 5.9 feet. Those measurements suggest a powerful bird, though not an immense one. A closer examination tells a different story. Nearly every feature emphasizes strength concentrated into the legs and feet. The lower limbs are unusually thick, the toes remarkably broad, and the talons curve into formidable hooks designed to penetrate flesh and maintain an unyielding grip after impact. The wings reveal another important detail. They are shorter and broader than those of soaring eagles that spend long periods gliding across open landscapes. Such proportions allow swift movement through tangled woodland where branches leave little room for error. Precision becomes more valuable than prolonged speed. Each feather, muscle, and joint contributes to controlled bursts through crowded canopy instead of extended travel across wide skies. Much of the hunt unfolds without movement. A crowned eagle may remain perched for long intervals, blending into layers of leaves while watching the forest below. The surrounding animals continue feeding, climbing, and calling, unaware that they have entered the hunting range of an observer capable of explosive acceleration. Once the distance becomes favorable, the bird launches with astonishing force. Both feet strike almost simultaneously, concentrating momentum through the talons into the head, neck, or upper body. The impact alone can disable prey before any sustained struggle develops, while extraordinary grip strength prevents escape even from animals that greatly exceed the eagle's own weight. Field observations gathered over many years have steadily expanded the known range of its prey. Researchers have documented kills that include antelope calves, substantial monkeys, and large baboons. Some victims have weighed as much as 30 kilograms, which is about 66 pounds. That figure approaches 8 times the eagle's own body mass. Such captures once seemed improbable, yet repeated observations from different regions established that they belong within the ordinary capabilities of this remarkable predator rather than representing rare accidents. Transport does not depend upon lifting an entire carcass through uninterrupted flight. Feeding may begin where the attack occurred before selected remains are carried away in stages, a strategy fully consistent with the evidence preserved at fossil sites. The effectiveness of the crowned eagle, therefore, rests upon technique as much as physical power, combining patience, surprise, leverage, and relentless grip into a hunting system refined across immense spans of evolutionary time. Viewed in this light, every aspect of the crowned eagle forms part of a single architectural purpose. The oversized feet, reinforced legs, broad wings, crushing talons, and ambush strategy all converge toward one task, overcoming prey considerably larger than the hunter itself. Early members of the human family occupied forests where that design already operated with relentless efficiency, placing young hominins well within the range for which this predator had long been perfected. Patterns become clearer when they are measured across many forests instead of a single valley or nesting site. Decades of observation have allowed researchers to follow crowned eagles through rainforests stretching across sub Saharan Africa, recording prey carried to nests, identifying bones left after feeding, and capturing hunting behavior with remote cameras. Each study adds another piece to the same picture until scattered observations settle into one unmistakable ecological pattern. Throughout equatorial rainforest habitats, primates form an extraordinary share of the crowned eagle's diet. Published field investigations conducted across multiple regions show that monkeys and other primates account for anywhere between roughly one quarter and more than four-fifths of all prey, depending upon local conditions and the species available within each forest. These conclusions do not rest upon isolated encounters. They emerge from direct observation, continuous nest camera recordings, and careful examination of prey remains accumulated over complete breeding seasons. 12 independent dietary studies, carried out across the eagle's geographic range, arrive at remarkably consistent conclusions despite differences in landscape and local wildlife communities. Some locations reveal an even stronger pattern. Research carried out in Uganda documented active nests through entire breeding cycles, identifying each prey animal delivered by adult birds. More than 82% of all recorded prey belonged to primate species. Such consistency is striking because predators often broaden their diet whenever opportunities change. Crowned eagles certainly take other animals when circumstances allow, including antelope calves, small antelope, hyraxes, squirrels, birds, reptiles, and other mammals. Even so, where healthy primate populations thrive, those animals remain the principal target with impressive regularity. Among living eagles, this degree of specialization stands apart. Many powerful raptors consume a wide assortment of prey, shifting from rabbits to waterfowl, rodents, reptiles, or fish according to season and habitat. The crowned eagle follows a different ecological path. Its closest evolutionary relatives display similar tendencies, yet no other eagle species on Earth demonstrates such a persistent focus upon primates across such an extensive portion of its range. The preference appears repeatedly wherever suitable forests continue supporting both hunter and prey. That relationship carries profound meaning when viewed beside the fossil evidence already assembled. Early members of the human family occupied these same broad regions for immense spans of time. They moved through woodland edges, climbed trees, gathered food, cared for offspring, and crossed landscapes where crowned eagles had already perfected their hunting strategy. The overlap was not occasional. Predator and hominin shared the same environments across countless generations, creating repeated opportunities for encounters that rarely leave traces capable of surviving into the present. The crowned eagle, therefore, occupies a distinctive place in the story of human origins. It is neither an imagined reconstruction nor a vanished branch of evolution inferred only from scattered fossils. Living birds continue practicing the same ambush technique, selecting comparable prey, nesting within familiar forests, and leaving behind the same distinctive forensic signatures documented by modern researchers. Every successful hunt adds another contemporary example of behaviors already recognized upon the Taung Child. Viewed together, the dietary studies reveal an ecological partnership shaped by evolution itself. Across the very landscapes where early hominins lived, there existed a predator whose principal hunting focus rested upon fellow primates. The evidence stretches from modern forest canopies to fossilized bone, connecting living observation with a death recorded millions of years ago through marks that endured until science finally learned how to read them. A fossil can preserve the final instant of a life, yet living animals preserve something different. Their bodies and behavior carry memories written by evolution, refined across spans of time so immense that no individual experience could explain them. In forests and woodlands throughout Africa, modern primates continue responding to dangers that shaped their ancestors for millions of years. Those responses remain measurable today, offering another line of evidence that reaches beyond stone and bone. Among the clearest examples are vervet monkeys. Their vocal communication includes distinct alarm calls matched to different categories of predators. One call warns of leopards and other hunters approaching across the ground. Another is reserved specifically for raptorial birds descending from above. Each signal produces a different response within the group. A ground predator sends monkeys climbing into trees where trunks and branches provide protection. An aerial predator triggers the opposite reaction, driving individuals toward dense cover while scanning the canopy and open sky. The difference is precise, immediate, and remarkably consistent across populations. Perhaps the most revealing discovery concerns the youngest members of these groups. Infant vervet monkeys display appropriate reactions to aerial alarm calls before acquiring meaningful personal experience with hunting eagles. Their responses appear long before repeated encounters could teach them every detail of survival. Experience gradually improves accuracy, yet the underlying tendency already exists. Evolution has supplied the first draft, allowing learning to refine what natural selection established across countless generations. Comparable patterns appear among many other African primates. Researchers studying geographically separated populations have documented specialized warning systems for predators approaching through the air. The details differ from one species to another, reflecting separate evolutionary histories, yet the broader pattern remains strikingly similar. Independent lineages, living across distant forests and savannas, developed distinct methods for recognizing and communicating the same category of danger. Such widespread convergence points toward selection pressure operating over immense areas for extraordinary lengths of time. Observation extends beyond vocal communication. Chimpanzees, bonobos, and several monkey species regularly perform coordinated upward scanning whenever they enter exposed spaces. Members of the group interrupt feeding or travel to inspect the sky while companions continue watching surrounding vegetation. These complementary patterns differ from the vigilance shown against predators moving across the ground. Field researchers interpret this behavior as another enduring consequence of aerial predation, one preserved, because repeated survival favored groups capable of sharing attention between earth and sky without sacrificing awareness of either. Such findings have encouraged broader discussion about human evolution itself. Some researchers propose that persistent aerial danger demanded rapid recognition, coordinated communication, flexible decision making, and careful cooperation within social groups. Individuals who detected approaching predators sooner, interpreted warning calls more accurately, or responded collectively may have enjoyed a measurable survival advantage. Across immense evolutionary intervals, those small differences could have favored increasingly sophisticated perception, stronger social coordination, and expanding cognitive abilities among early members of the human family. This idea remains an active scientific hypothesis rather than an established conclusion, yet it rests upon observable behavior still present in living primates. The crowned eagle did more than remove individuals from ancient populations. It may also have shaped the minds of those that survived, rewarding awareness directed not only across the landscape, but into the air above. If that possibility proves correct, the hunter that ended the life of the Taung Child belongs to more than a tragic chapter of our distant past. It may also occupy a place within the deeper evolutionary story of how our lineage gradually became what it is today, before another landscape carries this journey toward a different horizon. Every thread gathered across the African landscape now rests upon a single thought that reaches beyond one fossil, one predator, or one place. The crowned eagle left evidence in bone, behavior, and living ecology. Its influence stretched across immense spans of time, shaping generations that disappeared long before written history. A natural question follows from that record. Was this relationship confined to Africa alone, belonging only to distant relatives whose lives ended millions of years before our own species appeared upon the world? The evidence leads elsewhere. It crosses oceans and enters a land separated from Africa by extraordinary distance, where evolution unfolded within remarkable isolation. On those islands, another eagle emerged, following a different path while arriving at a similar destination. Generation after generation favored increasing size, greater strength, and unmatched power until the result became the largest bird of prey known to science. It occupied forests unlike those of Africa, pursued different animals, and ruled a landscape untouched by terrestrial, mammalian predators. Yet the role it played echoed the pattern already revealed. Once again, the sky belonged to a hunter capable of overwhelming prey far larger than itself. One difference transforms the story completely. The African chapter reaches us through fossils preserved across millions of years, requiring careful forensic reconstruction before its events become visible. The next chapter unfolds close enough to the present that people themselves entered the landscape while the great eagle still lived. There is no separation of geological ages, placing humans safely beyond its reach. The timelines overlap directly, linking this predator with our own species rather than earlier branches of the human family tree. The bird known as Haast's eagle did not vanish before people reached its island home. It remained alive, breeding, hunting, and occupying the highest place within its ecosystem when the first human settlers arrived in what is now called New Zealand. Those arrivals occurred roughly 750 years ago. That span is astonishingly brief against the immense scale of evolutionary history. The ancestors of people living today shared the world with this eagle. The encounter belongs neither to remote prehistory nor to forgotten geological eras. It unfolded within a period that almost reaches recorded human memory. Such proximity changes the perspective entirely. The question no longer concerns whether a great eagle possessed the physical ability to attack members of the human family. The African evidence has already demonstrated that possibility through careful forensic reconstruction. The next landscape asks something more immediate. What happens when an eagle, surpassing every living raptor, encounters fully modern human beings walking into its territory for the first time, carrying their own stories, ambitions, and fragile assumptions about the world around them? The distance between southern Africa and the forests of New Zealand is immense, yet the underlying theme remains continuous. Evolution repeatedly produced aerial hunters whose capabilities extended far beyond ordinary expectations. One chapter survived within fossilized bone. The next survives much closer to the present, where memory, archaeology, and natural history begin to overlap. The story therefore leaves deep time behind and steps into an age inhabited by people unmistakably like ourselves, where the greatest eagle ever known still watched from the trees above, and where the relationship between humans and the sky acquired an entirely different dimension. Far from the continental landscapes where the earlier story unfolded, Two islands rested within the South Pacific, separated from every major landmass for approximately 80 million years. Such an immense span of isolation allowed evolution to follow its own course, free from many of the influences shaping life elsewhere. Plants, insects, reptiles, and birds responded to challenges found only within these shores, creating an ecological world unlike any other that survived into recent history. Across continents, mammals occupied nearly every major role in nature. Some grazed open plains, others browsed forests, hunted smaller animals, burrowed beneath the soil, or patrolled as dominant predators. New Zealand developed along a different path. Native terrestrial mammal predators never became part of its living community. Without foxes, wolves, cats, or other ground hunters directing evolutionary pressures, birds expanded into opportunities that remained unavailable elsewhere. Some sifted insects from leaf litter, others browsed vegetation. Several became towering herbivores whose lives resembled those of deer, horses, or antelope found across distant continents. Among these remarkable birds stood the moa. 9 distinct species eventually occupied different habitats throughout the islands, each adapted to particular forests, shrublands, or open country. The smallest scarcely exceeded the size of a large turkey. The greatest members of the group reached nearly 3.6 meters in height, that is nearly 12 feet, when stretching their necks upward. The largest individuals weighed as much as 230 kilograms. Such dimensions made them the tallest, flightless birds known to science, surpassing every living relative in stature while feeding upon leaves, twigs, fruits, and other vegetation gathered from different heights within the forest. Their immense size reflected a landscape where flight gradually lost much of its value. Wings diminished across countless generations because escape through the air offered little advantage against dangers that scarcely existed upon the ground. Powerful legs replaced the need for flight, allowing these birds to travel through dense vegetation while reaching food unavailable to smaller species. Their lives unfolded at an unhurried rhythm, shaped by abundance instead of relentless pursuit. Generations passed beneath these conditions until behaviors became deeply established. Ground level inspired little urgency because no native predator had evolved there capable of bringing down a full-grown moa. Herd formations remained comparatively loose. Defensive circles never developed into elaborate strategies. Vigilance toward approaching footsteps carried limited value across millions of years, leaving no persistent selection pressure for elaborate terrestrial escape responses. The absence of danger from below never meant complete safety. Another direction still demanded attention. The open space above the forest canopy remained part of every day, and natural selection never abandoned that dimension. Survival depended upon recognizing movement descending through the air with astonishing speed. Any predator capable of exploiting these enormous birds could never rely upon endurance across open ground. It required overwhelming force delivered within moments, ending resistance before size alone became an obstacle. Every feature of this remarkable ecosystem gradually prepared the stage for such a hunter. Abundant prey grew larger across evolutionary time. Ground defenses remained comparatively modest. Forests provided elevated vantage points, and narrow spaces favoring swift maneuverability instead of prolonged pursuit. The ecological puzzle assembled itself piece by piece until only one element remained absent. Evolution answered that final requirement by producing a bird unlike any other ever recorded, one whose extraordinary proportions matched the extraordinary world that had shaped it. One predator stood apart even within this extraordinary island world. Its existence seemed almost disproportionate to everything around it, as though evolution had stretched familiar proportions until they reached an entirely different scale. This was Haast's eagle, known scientifically as Hieratus mori, the largest eagle ever identified anywhere in the fossil record. No living bird of prey has matched its combination of mass, power, and specialized hunting ability. The largest females reached an estimated body weight between 10 and 18 kilograms. Their wings spread as much as 3 meters, which is about 9.8 feet, from tip to tip. Although impressive, those broad wings were only part of the story. The legs were immensely developed, ending in feet armed with talons measuring up to 75 millimeters, which is about 3 inches. Those claws exceeded the length of a tiger's and were supported by muscles capable of producing extraordinary gripping force. Every strike concentrated enormous pressure into a small area, allowing the bird to pierce flesh and crack bone belonging to prey many times heavier than itself. Viewed beside modern eagles, the difference becomes unmistakable. The harpy eagle, widely regarded as one of today's most formidable birds of prey, reaches a maximum weight of around 9 kilograms. Haast's eagle exceeded even that impressive benchmark by a considerable margin. The increase represented far more than a gradual enlargement. Nearly every aspect of its anatomy shifted toward overwhelming strength. Short, broad wings provided rapid acceleration through forest openings. Thick leg bones resisted tremendous impact forces. Massive feet became the principal tools of the hunt, turning the entire body into a living mechanism designed to stop enormous prey within moments of contact. Its ancestry makes this transformation even more remarkable. Genetic evidence indicates that Haast's eagle descended from a comparatively small Australian eagle weighing less than 1 kilogram. Such an ancestor would have resembled an ordinary, medium-sized raptor, occupying a role familiar across many landscapes. After reaching New Zealand, however, the lineage entered an environment unlike any other. Generation after generation experienced pressures unlike those faced by relatives elsewhere. Across hundreds of thousands of years, body size expanded until descendants weighed more than 15 times as much as the birds from which they originated. Few examples within the avian fossil record illustrate evolutionary change so dramatically. Large bodies usually demand equally large ancestors, yet this lineage overturned that expectation through sustained natural selection. Every increase in size offered advantages when confronting the giant herbivores roaming the islands. Greater weight meant stronger impact. Larger feet produced deeper penetration. More powerful muscles improved control over struggling prey. Increment by increment, each adaptation favored individuals capable of bringing down animals that smaller hunters could never overcome. The destination of that long transformation was written into the landscape itself. The moa represented an abundant food source, unlike anything available elsewhere on Earth. Their immense bodies supplied enough nourishment to sustain an eagle that invested heavily in muscle and strength instead of long-distance soaring. Evolution continued refining that relationship until predator and prey became matched through countless generations. Haast's eagle did not become enormous through chance alone. It became enormous because the islands held prey that demanded extraordinary force, and every successful hunt carried that legacy forward into the next generation. Scattered across the valleys of New Zealand, broken bones preserved a pattern that refused to disappear. Each discovery added another fragment to the same story until the arrangement became too consistent to dismiss. The marks did not belong to chance, weather, or the slow pressure of sediment. They belonged to repeated encounters between one hunter and one prey animal, played out across hundreds of thousands of years in forests that no longer exist. The body of Haast's eagle reveals how those encounters unfolded. Although its wings stretched to nearly 3 meters, which is about 10 feet, they were shorter in proportion to its body than might be expected for a bird of such extraordinary size. Broad wings and a compact shape favored rapid movement through dense woodland instead of prolonged, soaring across open country. Every feature points toward an ambush hunter that relied on concealment, explosive acceleration, and precise control among towering trees. The forest itself became part of the hunting strategy, providing elevated perches from which the eagle could watch the movements of moa without drawing attention. When the moment arrived, the attack unfolded in only a few heartbeats. Launching from the canopy, the eagle descended at speeds estimated to reach 80 kilometers per hour, which is about 50 miles per hour. Both feet struck at the same instant, concentrating the force of impact onto the hindquarters and pelvis of the moa. The enormous talons drove through muscle and into bone, anchoring the predator while momentum forced its prey downward. A bird weighing many times more than the eagle suddenly lost balance, and gravity completed what the collision had begun. Once the moa collapsed, the final movements followed a sequence suggested by both anatomy and fossil evidence. The eagle maintained its grip while delivering powerful blows with its beak near the base of the skull. Damage in that region appears repeatedly among recovered moa remains, matching the position expected from a predator seeking to disable the neck and reach vital tissues. The combination of talon injuries to the pelvis and characteristic trauma around the skull forms a distinctive signature that appears again and again, preserved across separate fossil localities. Among the richest sources of this evidence is Pyramid Valley, where researchers have examined large collections of moa skeletons. Around 10% of those remains display talon punctures, pelvic injuries, and skull damage that fit the same sequence of attack. Independent discoveries from other sites reinforce the pattern. Together, they transform scattered bones into a coherent behavioral record. This is more than an anatomical proposal built from the shape of a skeleton. It is a repeated trace of predation recorded in the prey itself with remarkable consistency. The moa possessed tremendous size, yet millions of years without native land predators had shaped its instincts in unusual ways. Flight had long since disappeared from its lineage, and there was little evolutionary pressure to develop coordinated defensive formations or rapid escape responses against threats approaching along the ground. Survival depended on a landscape where danger descended through the forest canopy. Within that setting, Haast's eagle refined an attack unlike any known elsewhere, meeting prey that lacked an effective answer. Across countless generations, predator and prey remained locked in that enduring relationship, each preserving the place of the other within an island world unlike any before or since. For longer than the human mind can comfortably imagine, the highest place in New Zealand's living world belonged to a single hunter. Seasons arrived and departed. Forests expanded and shifted. Rivers altered their paths, and generations of enormous flightless birds lived and vanished beneath the same watchful presence. Throughout those immense stretches of time, Haast's eagle remained the undisputed apex predator, occupying a position that nothing else challenged. Its authority reached across an ecosystem unlike any other on Earth. No native land mammal hunted the forests. No rival predator contested its kills. Every stage of its life unfolded within an environment that had developed alongside it across hundreds of thousands of years. High mountain valleys offered secure nesting places, while broad lowland forests supported the great populations of moa that formed the foundation of its existence. From elevated nesting grounds to shaded woodland, every movement fit within a landscape that consistently rewarded the same successful strategy. The abundance of moa gave this relationship extraordinary stability. Across both main islands, these giant birds occupied grasslands, shrublands, wetlands, and forests. They reproduced at a measured pace, yet their populations remained substantial because almost nothing besides Haast's eagle regularly preyed upon healthy adults. Juveniles provided easier opportunities, while mature individuals supplied immense quantities of food after a successful hunt. From the eagle's perspective, the resource appeared dependable across generation after generation, allowing natural selection to favor increasing specialization instead of flexibility. Such enduring security shaped every feature of the predator's biology. Large body size demanded substantial meals, yet plentiful prey made that investment worthwhile. Extensive hunting territories reduced competition between neighboring pairs, while dependable resources supported those broad ranges. Reproduction proceeded gradually, with relatively few offspring receiving prolonged parental care. Evolution preserved these characteristics because the surrounding world remained remarkably consistent. Little encouraged rapid adjustment when the conditions supporting survival changed so little across immense spans of time. Even the eagle's anatomy reflected confidence and continuity. Massive talons, tremendous gripping strength, powerful legs, and a body constructed for overwhelming ambush strikes represented costly biological investments. These traits excelled within a world filled with giant flightless birds, and they carried few disadvantages while that world endured. Every successful season reinforced the same evolutionary direction. Every generation inherited adaptations refined for an ecosystem whose balance appeared permanent. The relationship between predator and prey stretched so deeply through time that it exceeded the existence of our own genus. Long before the earliest members of humanity appeared, this island partnership had already settled into its enduring rhythm. Forests echoed with familiar patterns of life, and each generation inherited conditions that closely resembled those experienced by the one before it. Stability became the defining feature of the entire system, shaping both hunter and hunted with remarkable precision. No evolutionary pathway prepared Haast's eagle for abrupt disruption because disruption had never become a meaningful force in its history. Every successful adaptation assumed tomorrow would resemble yesterday. Every instinct depended upon landscapes filled with moa and untouched by unfamiliar competitors. Then, sometime between the years 1250 and 1280, unfamiliar vessels reached the coastline. Human beings stepped ashore carrying abilities unlike anything the islands had encountered, and within their arrival rested the first change that the eagle's long history had never prepared it to face. Across the open Pacific Ocean, long before charts or compasses guided distant voyages, skilled navigators followed stars, winds, waves, and the movements of birds until unfamiliar mountains rose from the horizon. Sometime between the years 1250 and 1280, the Polynesian ancestors of the Maori reached New Zealand, completing one of the greatest achievements in the history of human exploration. Their arrival connected these isolated islands with the wider human world for the first time. The newcomers did not arrive unprepared. They carried generations of knowledge gathered from settling islands scattered across the Pacific Ocean. Along with carefully tended crops and practical tools came fire, domestic dogs, and the Polynesian rat, each becoming part of the changing landscape. Their hunting traditions had been refined through repeated journeys into unfamiliar environments where survival depended upon recognizing opportunity quickly and using available resources with remarkable efficiency. Every successful settlement strengthened those skills, and New Zealand presented opportunities unlike any they had encountered before. Among the most extraordinary discoveries were the moa. Towering birds wandered through forests, shrublands, and open country in astonishing numbers. Having evolved without human hunters, they showed little instinctive caution toward people approaching on foot. Their size promised abundant food, while their behavior required no elaborate strategy to exploit. Spears, coordinated hunting parties, and controlled burning of vegetation proved more than sufficient. From the viewpoint of the arriving communities, these immense birds represented a resource of extraordinary abundance, capable of sustaining expanding settlements across both main islands. As people spread farther into the landscape, they entered the same forests, valleys, and open spaces that had long belonged to Haast's eagle. For countless generations, the eagle had relied upon moa as its principal food source, occupying an ecological position without rivals. Human hunters now pursued those very animals with growing success. Every moa taken by people became one fewer available to the great raptor. Unlike the eagle, human beings adapted rapidly, shared knowledge across generations, developed improved hunting methods, and cooperated in groups large enough to reshape the balance of the ecosystem within only a handful of lifetimes. Nothing in the eagle's evolutionary history had prepared it for such a competitor. Its biology reflected an environment where prey remained dependable and no other hunter removed them at comparable speed. Large territories, slow reproduction, and intense dietary specialization had served it well across hundreds of thousands of years. Those same strengths now became limitations. Evolution had equipped the eagle to master its traditional world, not one transformed by an intelligent newcomer capable of altering forests, harvesting prey, and expanding into nearly every suitable habitat. The encounter carried uncertainty from the human perspective as well. Adults traveling across exposed ground, or children wandering beyond the protection of their families during the early morning or fading evening light, entered the hunting domain of a predator unlike anything their ancestors had known on the islands of the tropical Pacific. Above the forest moved a bird powerful enough to overpower animals far heavier than itself, striking with overwhelming force before returning to the canopy. For a brief period in history, two remarkably successful hunters shared the same landscape, each encountering the other without the benefit of any evolutionary memory, and the balance that had endured for ages began to shift beyond recovery. Across the mountains and forests of New Zealand, memories of an immense bird endured long after its final flight. Those memories lived within Maori oral tradition, carried through generations with a level of consistency that drew the attention of historians, ornithologists, and archaeologists alike. The bird appeared under names such as Poakai and Hokioi, not as a distant symbol or supernatural spirit alone, but as a living creature remembered for its appearance, its hunting habits, and the places where it was said to rule the sky. These traditions emerged from communities separated by distance, preserved independently across both the North Island and the South Island. Although details varied in the natural way that oral histories evolve, the central description remained strikingly stable. The bird was immense, capable of astonishing speed during an attack, clothed in dark feathers marked with lighter streaks, and crowned with a noticeable crest of reddish feathers upon its head. It possessed the strength to seize exceptionally large prey and carry it away. Such consistency becomes more compelling when the accounts are considered together rather than in isolation, revealing recurring details that align with what later science uncovered from fossil remains. The stories also described a pattern of movement that fits the reconstructed ecology of Haast's eagle. It nested among rugged mountain slopes and descended into forests, river valleys, and open country in search of food. Individuals separated from their companions appeared repeatedly within these accounts. Children wandering beyond the protection of a village, or adults traveling alone during the first light of morning or the fading light of evening, were remembered as being especially vulnerable. The emphasis rested less upon random encounters than upon moments when isolation created opportunity for an attack from above. One account, recorded during the 1870s, described the bird with remarkable precision. Its coloring, the reddish crest, its extraordinary size, and the speed of its descent formed a portrait unlike any other known bird in New Zealand during historical times. More than a century later, ornithologists examining the description concluded that it almost certainly reflected direct observation of Haast's eagle preserved within cultural memory instead of an entirely mythical invention. The correspondence between the traditional account and the recovered anatomy reached beyond coincidence, joining independent forms of evidence separated by generations. Another record, written in the year 1878 by missionary James Weststack, preserved an even more detailed tradition. It identified a particular spur on a named mountain as the nesting place of a puakai. From that location, the bird was said to launch repeated attacks upon nearby people, taking men, women, and children to feed both itself and its young. Such geographical precision differs from stories untethered to real landscapes. It connects memory to recognizable terrain, allowing later researchers to compare tradition with ecology and fossil evidence. Scientists approach oral traditions with careful evaluation, neither accepting every account without question nor dismissing them because they originate outside written history. In this case, independent tribal traditions, consistent physical descriptions, recognizable hunting behavior, named locations, and anatomical evidence recovered from the ground all point toward the same remarkable conclusion. The echoes preserved within Maori memory appear to describe a predator that truly shared the islands with people, leaving traces not only in fossil bone, but also in the stories carried from one generation to the next. Measured against the physical evidence already gathered, the question becomes narrower than it first appears. The issue is no longer whether Haast's eagle possessed extraordinary strength. Its skeleton, talons, and reconstructed hunting behavior have already established that. The remaining question is whether an animal built to overpower the largest birds on Earth could also have attacked people in the ways preserved within Maori tradition. When the anatomy is examined alongside the biology, the answer becomes surprisingly straightforward. The largest females are estimated to have weighed as much as 18 kilograms, placing them far beyond the size of any living eagle. Their talons reached approximately 75 millimeters in length, almost 3 inches, and were attached to feet built for tremendous gripping power. Biomechanical studies indicate that the force delivered through those feet was sufficient to drive the talons into the pelvis of a moa, weighing close to 230 kilograms, or about 507 pounds. The strike relied on momentum as much as strength, concentrating enormous force into a brief instant before the prey could recover its balance. Placed beside those figures, the proportions of a human become easier to evaluate. An average adult commonly weighs between 60 and 80 kilograms, or about 132 to 176 pounds. That range overlaps with several medium-sized moa species that formed part of the eagle's natural prey. A child weighing between 20 and 30 kilograms, or about 44 to 66 pounds, would have represented considerably lighter prey than many animals the eagle was already adapted to subdue. Nothing within the reconstructed mechanics of the attack suggests that such a target exceeded the bird's physical limits. Researchers who have examined this possibility generally reach the same conclusion. Using the attack sequence reconstructed from skeletal anatomy and fossil damage, the eagle possessed the capability to kill an adult human. A rapid descent from above, impact directed toward the back and pelvis, deep penetration by both feet, collapse driven by combined speed and body weight, followed by a powerful bite delivered near the base of the skull, matches the pattern already established for attacks upon moa. The same anatomical equipment required no modification to perform the same sequence against a human. The oral traditions also describe children being carried away, an element that fits comfortably within scientific reconstruction. Fossil evidence from multiple moa sites indicates that Haast's eagle regularly transported portions of prey across the landscape to feeding locations and nesting areas. A child weighing 20 to 30 kilograms, or about 44 to 66 pounds, falls within a range considered physically manageable for a bird of this size, particularly when feeding young at a nest positioned high above the forest floor. For that reason, the scientific conclusion reaches an unusual point of agreement with traditional knowledge. Researchers do not argue that every individual story must represent a literal historical event. Instead, they observe that no anatomical, ecological, or behavioral evidence contradicts the central claim. The recovered skeleton, the reconstructed hunting method, the carrying capacity, and the consistent traditions preserved across independent communities all remain compatible with one another. Together, they describe a predator fully capable of the encounters remembered for centuries, leaving open the possibility that those enduring accounts preserve authentic memories of the final age when one of Earth's greatest eagles still hunted beneath the same sky as human beings. The story leaves traces in more than memory. Across archaeological sites in New Zealand, another kind of record has survived within the layers of everyday life. Refuse accumulated outside settlements, built gradually through repeated occupation, preserved food remains, broken tools, and discarded objects across centuries. These deposits, known as midden sites, became an unexpected archive of the relationship between people and the largest eagle that ever lived. Among shells, fish bones, charcoal, and the remains of many hunted animals, archaeologists recovered bones belonging to Haast's eagle itself. Their presence carries a clear meaning. The bird was not merely observed from a distance or remembered through spoken tradition. It was hunted, butchered, and brought back to settlements where its body was processed alongside other resources gathered from the surrounding landscape. The evidence rests within the physical remains left behind by daily activity, preserved in the earth until excavation revealed them centuries later. Some of those recovered bones bear signs of purposeful human use beyond consumption. Strong wing bones and leg bones were shaped into tools and worked objects, demonstrating that the eagle also provided valuable material after death. Such finds have appeared at multiple archaeological locations, suggesting this practice was neither isolated nor accidental. Every crafted object represents an encounter between people and predator, transformed into something that remained useful long after the hunt had ended. Material culture preserves those encounters with a permanence that spoken stories alone cannot provide. Rock art contributes another strand to the same record. In caves and rock shelters across parts of the South Island, Artists created images of large birds whose proportions differ noticeably from the smaller eagles that survived into more recent times. Broad bodies, powerful hooked beaks, shortened wings, and commanding talons appear with an attention to form that resembles direct observation. These drawings lack the exaggerated features often associated with symbolic creatures. Their balance between realism and simplicity suggests that the artists were recording an animal familiar enough to recognize, rather than inventing one from imagination alone. Taken separately, each line of evidence offers only part of the picture. Oral traditions preserve remembered encounters. Archaeology uncovers hunted remains and crafted objects. Rock art preserves visual impressions left by observers who shared the landscape with the bird itself. Together, these records strengthen one another. None exists in isolation, and none depends entirely upon another for credibility. Instead, each emerges from a different source while pointing toward the same living creature. The relationship that appears through this combined evidence is more complex than one of hunter and victim. The Maori did not exist only under the shadow of Haast's eagle, nor did the eagle exist merely as another resource waiting to be harvested. Both occupied the same forests, valleys, and mountain slopes while competing within a shared environment shaped by opportunity and danger. Encounters sometimes ended with the eagle feeding. Others ended with people carrying the bird back to their settlements. Knowledge of its habits became woven into memory because survival depended upon recognizing them. That reciprocity offers one final piece of evidence. Animals that never existed do not leave bones inside settlements, become raw material for carefully fashioned tools, or appear repeatedly in artwork grounded in recognizable anatomy. They are not remembered across generations with consistent detail rooted in specific places. The combined record speaks through earth, stone, craftsmanship, and tradition, preserving the outline of a predator that remained part of human experience until history itself had already begun. Few endings begin with intention. More often, they emerge from ordinary choices repeated across seasons until a pattern becomes impossible to reverse. The final chapter of Haast's Eagle followed that quieter path. No campaign was organized against the great predator, and no deliberate effort sought its disappearance. The change began with another animal whose place within the islands had remained secure for hundreds of thousands of years. For the newly arrived Maori communities, the moa represented an extraordinary source of food. These large birds had spent countless generations in a world without terrestrial mammal hunters. They possessed no inherited tendency to retreat from people walking toward them. Coordinated groups, armed with spears and practiced hunting knowledge, encountered prey that offered little effective resistance. Archaeological sites preserve the scale of this harvest with remarkable clarity. Large moa processing areas contain extensive accumulations of bones bearing organized butchery marks, showing repeated and systematic use instead of isolated or occasional kills. The pattern reflects an efficient food economy built around the largest and most accessible resource available. Across both islands, the consequences unfolded with unusual speed. Within roughly 150 to 200 years after human arrival, every known species of moa had disappeared. That span is remarkably brief when measured against the long history that produced these birds. It is also shorter than the time that the United States has existed as a nation. An ecological relationship that had endured across hundreds of thousands of years dissolved within only a handful of human generations. The hunters responsible for this transformation could not have recognized the wider consequences of their success. Their goal was nourishment for families and communities, not the destruction of an ecosystem. Every successful hunt supplied meat, feathers, and bone for immediate use. Each individual harvest appeared reasonable when viewed on its own. Across decades, however, those separate decisions accumulated into a decline that neither the moa nor their greatest predator could withstand. Haast's eagle had evolved around remarkable stability. Its body, hunting behavior, breeding pattern, and territorial range all reflected confidence that large moa would remain available. Such specialization had served it exceptionally well for an immense stretch of time. It possessed no alternative prey capable of replacing fully grown moa in sufficient numbers. Smaller birds could provide temporary meals, yet they could not sustain a predator built on such extraordinary scale. As the great flightless birds became scarce, every nesting season demanded greater effort while offering fewer opportunities. Unlike adaptable predators that shift readily toward different food sources, Haast's eagle occupied a narrow ecological role. Large body size required abundant energy. Raising young demanded dependable access to substantial prey. Population recovery depended upon successful breeding over many years. Once the supply of moa fell below a critical threshold, those interconnected requirements began failing together. Adults struggled to maintain territories. Fewer chicks survived. Breeding pairs gradually disappeared from landscapes they had ruled for ages. The remarkable irony is that the eagle itself remained largely untouched by the process that doomed it. Human hunting contributed to its decline, yet the decisive blow had already been delivered through the disappearance of the prey upon which its existence depended. The greatest predator in New Zealand did not lose its place because another hunter proved stronger in direct conflict. It faded because the foundation supporting its entire way of life had been steadily removed, one moa at a time, until nothing remained capable of sustaining the ruler of the islands. Extinction did not arrive with a final battle or a single disastrous season. It unfolded through absence. Each valley that once held towering moa became a little less capable of supporting the predator that had depended upon them for an immense span of time. Across the islands, familiar hunting grounds remained in place. The forests still stretched across the hills, and mountain nesting sites still overlooked the landscape. Only the prey had faded away, leaving behind a world that appeared recognizable while no longer providing what the eagle required to survive. Haast's eagle possessed no biological answer to this loss. Smaller birds of prey often respond to changing conditions by shifting toward different prey, broadening their diet when opportunity demands flexibility. Haast's eagle had traveled along a very different evolutionary path. Every aspect of its body reflected commitment to hunting exceptionally large animals. Its massive feet, powerful legs, crushing grip, and reinforced skeleton all served a single ecological purpose. Nothing else within New Zealand approached the size of the moa, and no collection of smaller animals could replace that vanished food source in a sustainable way. The crisis deepened through the eagle's own life history. Large eagles invest heavily in very few offspring, producing a single chick during a successful breeding cycle and often requiring years before raising another. That strategy functions well when food remains dependable across generations. Under conditions of severe prey shortage, however, the same strategy becomes a profound disadvantage. Adults struggling to find sufficient food cannot raise healthy young consistently, and every unsuccessful breeding season removes another opportunity for the population to replace itself. Territory added another limitation. Each breeding pair depended upon an extensive hunting range capable of supplying enough large prey throughout the year. Such territories could never exist close together, meaning the total number of Haast's eagles had always remained relatively small, even during the height of their success. Their population stretched across both islands in scattered pairs, separated by considerable distances. A species organized in that manner possesses little resilience when its primary food source disappears almost everywhere at once. The disappearance of the moa, therefore, reached every nesting territory simultaneously. Empty valleys could no longer support established pairs. Young birds searching for territories encountered landscapes already stripped of the prey needed to sustain adulthood. Older birds persisted for a time through experience and determination, yet each passing season narrowed the remaining possibilities. The decline advanced steadily because every generation inherited fewer opportunities than the one before it. By approximately 1400 to 1445, the last Haast's eagles had vanished. Their disappearance followed the extinction of the moa in remarkably close succession, revealing how completely the destinies of predator and prey had become intertwined. One could not endure without the other. Hundreds of thousands of years of shared evolution had produced extraordinary specialization, yet that same specialization offered no protection once the partnership collapsed. The closing of this lineage carries a remarkable contrast. For an immense stretch of natural history, Haast's eagle occupied the highest position within its island ecosystem. It faced no rival capable of replacing it, no persistent natural enemy, and no challenge that fundamentally altered its way of life. Every adaptation pointed toward long continued success. Then, within little more than the span of a few human generations, the foundation supporting that success disappeared. The ruler of New Zealand's skies did not fall because it became weaker. It vanished because the living world that had shaped it for ages changed faster than evolution could ever respond. Separated by oceans and by almost 3 million years, two discoveries illuminate the same forgotten chapter of human history. One comes from southern Africa, where the skull of the Taung Child preserved the unmistakable marks of an eagle attack. The other comes from New Zealand, where fossil evidence, archaeology, and enduring oral tradition together reveal the life of Haast's eagle, a bird so powerful that it occupied the highest place in its island ecosystem until its disappearance only a few centuries ago. Each story emerged through a different path of evidence, yet both arrive at the same destination. The Taung Child lived nearly 3 million years ago. Its bones carried small puncture wounds whose significance remained misunderstood for decades before careful forensic analysis showed that they matched the talons and beak of a large eagle related to the crowned eagle living in Africa. Today, Haast's eagle survived until roughly 6 centuries before the present, leaving behind skeletons, prey remains, archaeological traces, and detailed oral traditions that later proved consistent with its recovered anatomy. One story comes from fossil bone, the other is supported by bones, human memory, and the landscape itself. These predators belong to different evolutionary lineages and hunted in completely different environments. The African eagle inhabited woodland and savanna. Haast's eagle ruled the forests and mountains of New Zealand. Their preferred prey also differed. One hunted small primates among the trees, while the other specialized in enormous flightless moa that outweighed the eagle many times over. Even with these differences, both species relied upon the same fundamental strategy. They attacked from above with tremendous speed, using powerful talons to seize vital areas before delivering a fatal bite with the beak. The evidence supporting both accounts extends beyond interpretation alone. The Taung Child preserves puncture marks that correspond precisely with the spacing of eagle talons and damage patterns observed in modern eagle attacks. In New Zealand, moa skeletons repeatedly display impact injuries to the pelvis and skull that match the reconstructed hunting behavior of Haast's eagle. Oral traditions describing the great bird also align with anatomical evidence, ecological reconstruction, and archaeological discoveries made centuries after those accounts were first recorded. Independent lines of evidence converge instead of contradicting one another. Taken together, these discoveries reveal a recurring ecological relationship that is often overlooked. Human ancestors were not always the dominant hunters remembered in later history. For immense stretches of time, they also occupied the role of prey. In certain landscapes, danger approached across the ground. In others, it descended through the forest canopy on broad wings, leaving little opportunity to escape. The threat came from the sky as much as from the earth, shaping awareness, behavior, and survival across countless generations. Modern history is frequently told as the story of humanity's rise to ecological dominance. The deeper record preserved in fossils and archaeology offers a broader perspective. Before people transformed ecosystems across the world, ecosystems also shaped the people who lived within them. The Taung Child and Haast's eagle stand at opposite ends of that immense timeline, connected by physical evidence that reaches across continents and ages. Together they preserve the same enduring reality. For much of the time that beings recognizably human have existed on Earth, large aerial predators represented a genuine and recurring danger. The record has endured in bone, in tradition, and in the remarkable agreement between discoveries made worlds apart. Long after the last giant eagle disappeared, and the forests that once sheltered them had changed beyond recognition, an intriguing question remained. If aerial predators hunted our relatives for millions of years, and if evidence from both Africa and New Zealand shows that attacks from above were genuine parts of our evolutionary history, why does that danger seem so distant today? Many people instinctively notice movement near the ground before they think to search the sky. That contrast has become an important subject of research rather than a simple assumption. Among the strongest examples of inherited predator awareness is what scientists often call the snake detection hypothesis. Experiments involving humans, monkeys, and apes consistently show that snake shapes are recognized with remarkable speed. Infants who have never encountered a snake direct their attention toward its distinctive form more readily than toward many harmless objects. Adults also display faster visual processing and stronger automatic physiological responses when confronted with snake imagery. Researchers interpret these findings as the product of selection pressures extending across tens of millions of years, reaching back to the earliest members of the primate family. Responses to aerial predators tell a more complicated story. Many living primates possess distinct alarm calls reserved specifically for danger arriving from above. Vervet monkeys produce one call for leopards, another for snakes, and a different one for eagles. Each signal triggers a different escape strategy. An eagle alarm causes individuals to look upward, move beneath vegetation, or gather close together. Similar behaviors appear in several other primate species, suggesting that the threat of large hunting birds shaped their behavior over immense spans of evolutionary time. Humans retain some elements of that awareness, yet the response appears less deeply embedded than our reactions to snakes or large terrestrial predators. One explanation focuses on body size. As successive members of the human lineage gradually became taller and heavier, healthy adults moved beyond the practical carrying capacity of most birds of prey. Juveniles remained vulnerable for much longer, But the danger became concentrated within only one portion of the population instead of affecting every individual equally. Selection pressure, operating primarily upon children, may have produced a weaker universal instinct than one acting across an entire species. Another possibility centers on technology and cooperation. Fire altered nighttime safety. Stone weapons expanded defensive reach. Thrown spears, coordinated groups, and increasingly complex social behavior transformed encounters that had once favored an ambush predator. Large eagles could no longer rely upon isolated individuals moving through exposed landscapes with little protection. Cultural innovation changed conditions rapidly, perhaps more rapidly than biological evolution could reinforce or preserve specialized responses directed toward threats descending from above. Some researchers have suggested an additional perspective that is more difficult to measure but remains worthy of consideration. The underlying capacity may never have vanished completely. Modern environments rarely resemble the settings in which those ancient encounters occurred. Streets, buildings, enclosed vehicles, and organized communities surround daily life with layers of protection. Looking upward is no longer essential for survival in most places because the circumstances that once demanded constant vigilance have largely disappeared. Viewed through that broader lens, the pattern becomes easier to understand. Evolution does not preserve every response with equal strength forever. It reflects changing risks across changing worlds. The fossil record and the behavior of living primates together suggests that danger from the sky once occupied a meaningful place in our shared history, even if its echo now survives more clearly in evidence than in instinct. The disappearance of danger from the sky was not a sudden turning point. It unfolded gradually across hundreds of thousands of years, changing at different times in different places. Each generation inherited a world that differed only slightly from the one before it. Yet those small changes accumulated until the balance between predator and prey no longer resembled its ancient form. The threat did not vanish in a single age. It steadily lost the conditions that had once allowed it to flourish. One of the most important changes came with the growth of the human body itself. Early members of our lineage were considerably smaller than later species. A juvenile Australopithecine weighing around 10 kilograms presented a realistic target for a large eagle. As hominins increased in size, healthy adults became progressively more difficult to overpower. By the time fully grown Homo erectus commonly reached about 60 kilograms, an aerial attack carried much greater risk for the predator and much less chance of success. The danger narrowed instead of disappearing, remaining concentrated on children and isolated individuals. Social behavior transformed the equation even further. Larger, more coordinated groups reduced the opportunities available to ambush predators. Individuals spent less time alone, shared information more effectively, and responded collectively when danger appeared. Living primates still demonstrate this principle today through alarm calls and cooperative defense against birds of prey. Human ancestors almost certainly benefited from similar advantages as communication and social organization became increasingly sophisticated over evolutionary time. Control of fire added another layer of protection. Camps illuminated by flames extended safety beyond daylight hours and reduced the vulnerability associated with dawn, dusk, and darkness. A predator that depended upon surprise found fewer opportunities when groups remained active around controlled fire. Light, smoke, and the presence of several alert individuals together created an environment far less favorable to attacks from above than the open landscapes of earlier ages. Technology continued the same trend. Spears allowed people to threaten predators before physical contact became possible. Spear throwers increased both range and striking power. Later, bows and arrows extended defensive reach still farther. A large eagle perched within sight of an organized hunting party no longer represented an uncontested hunter. It had become another animal capable of being challenged, injured, or killed. Cultural innovation altered ecological relationships more rapidly than biological evolution alone could accomplish. Across much of the world, these developments steadily reduced the practical importance of aerial predation. Large hunting birds still existed, but the circumstances that had once made humans suitable prey became increasingly uncommon. One remarkable exception endured in New Zealand, where Haast's eagle evolved in isolation beside enormous flightless moa. There, the ancient relationship survived into a period when fully modern humans finally entered the landscape, creating one of the last documented encounters between people and a giant eagle capable of hunting them. When that final chapter closed, little remained except traces preserved in unexpected places. Fossil bones retained the marks of talons. Archaeological sites recorded encounters between predators and people. Living primates continued to display behaviors shaped by dangers their distant ancestors faced. Together, these fragments preserve the memory of an era when the sky demanded as much attention as the ground, even though that world has long since passed. There is a span of human history so immense that it reshapes the scale of everything that followed. It extends across millions of years, reaching farther back than language, farther than controlled fire, farther than the oldest stone tools that still survive beneath layers of earth. During that immeasurable stretch, our ancestors lived as one species among countless others, sharing landscapes where survival depended less on mastery than on enduring another day. For longer than any civilization has existed, and for longer than every recorded culture combined, something recognizably human remained visible, vulnerable, and capable of becoming another animal's prey. The story we usually tell begins much later. It opens with invention, adaptation, and growing control over the natural world. We picture upright figures shaping tools, gathering around flames, and gradually expanding into every environment on Earth. Those moments deserve their place, yet they do not stand at the beginning of our story. They stand near its middle. Before confidence became possible, caution filled each day. Before hunters spread across continents, countless generations survived by recognizing danger early enough to escape it. Vulnerability formed the foundation upon which every later achievement was built. The child whose skull rested within South African stone for nearly 3 million years belongs to that forgotten foundation. Its death was preserved with extraordinary clarity, marked by punctures that remained visible long after flesh had vanished. Those small openings in bone became a message carried across geological time, waiting until careful examination revealed their meaning. They describe a world where a shadow passing across open ground could signal an attack from above, and where paying attention to the sky carried the same importance as watching the land ahead. The discoveries from New Zealand reveal that this relationship did not belong only to distant prehistory. There, another lineage of giant eagle occupied a different landscape, separated by continents and immense spans of time, yet following remarkably similar ecological rules. Fossils, archaeological discoveries, and carefully preserved oral traditions converge upon the same conclusion. Human beings did not merely imagine such predators. They lived beside them, remembered them, and eventually left enough evidence for later generations to compare memory with anatomy. Independent lines of evidence meet without forcing agreement, each strengthening the others through unexpected consistency. Viewed together, these discoveries describe continuity rather than coincidence. Across changing climates, evolving species, and shifting continents, aerial predation remained part of the environment in which our lineage developed. Its influence changed as bodies grew larger, social groups expanded, weapons appeared, and fire transformed the night. Yet, the deeper pattern endured for an astonishing length of time before gradually fading from ordinary experience. The disappearance of the danger did not erase the history that came before it. What the bones ultimately preserve is neither despair nor triumph. They preserve duration. Generation after generation looked upward as naturally as they looked ahead, carrying forward the practical knowledge that survival often depended upon awareness shared within a group. Long before humanity reshaped the planet shaped humanity. The longest chapter of our story was written beneath an open sky, where endurance rested upon vigilance, companionship, and the accumulated wisdom of countless lives that succeeded in reaching another dawn. The ending of each eagle's story reaches beyond the birds themselves. Their fate reflects a truth about the living world that becomes visible only after enough time has passed for beginnings and endings to share the same horizon. For hundreds of thousands of years, Haast's eagle occupied the highest place in its island ecosystem. Generation followed generation with remarkable continuity, each bird inheriting a landscape that continued to provide everything required for survival. Then, within only a small fraction of that immense history, the balance unraveled. The change did not arrive through a stronger predator claiming the sky. It arrived through an alteration of the world beneath its wings. The people who reached those islands did not set out to erase the eagle. They hunted the flightless birds that offered abundant food, following practical knowledge refined across many generations of exploration and settlement. Every successful hunt solved an immediate need, while another consequence remained invisible. As the moa disappeared, the foundation supporting the great eagle dissolved beside them. The predator remained physically capable, its talons still powerful, its senses still refined, its flight unchanged. Yet no adaptation could replace the ecological relationship upon which its existence depended. A ruler of the sky could not survive after the ground beneath its history had been transformed. Far away, another eagle continued flying across African forests, where our distant relatives once looked upward with careful attention. That lineage endured while countless other predators vanished, carrying forward an evolutionary connection that stretches toward the earliest chapters of humanity. Today, however, the crowned eagle occupies forests that continue to shrink as landscapes change under expanding human activity. The primates upon which it depends also face growing pressure. The predator that may once have influenced the survival of our ancestors now persists within environments shaped increasingly by human decisions. Its future rests partly upon choices made by the descendants of creatures that once watched for its approach. There is a remarkable reversal within those parallel histories. One giant eagle disappeared because humanity unknowingly removed the living network that sustained it. Another survives while depending, in part, upon conservation efforts, protected habitats, and a broader understanding of ecological balance. The relationship between predator and prey has not been erased. It has been transformed into something neither lineage could have anticipated across the long passage of evolutionary time. The same intelligence that gradually escaped the reach of aerial hunters now possesses the ability to preserve or diminish the landscapes those hunters still require. Viewed across millions of years, dominance reveals itself as a temporary arrangement rather than a permanent achievement. Every apex predator stands upon countless relationships extending through plants, climate, prey, and habitat. Remove enough of those connections, and even the strongest hunter loses its place. Strength alone cannot preserve an ecosystem whose foundations have changed beyond recognition. The history of Haast's eagle demonstrates that truth with unusual clarity, while the continued existence of the crowned eagle reminds us that ecological relationships remain active in the present, shaped by choices unfolding each day. Perhaps that is the deepest thread linking these stories. Survival has never belonged exclusively to the powerful. It belongs to the intricate web that allows power to exist at all. When that web changes, every creature within it changes as well, from the smallest prey to the hunter circling high above, and finally to the species that now possesses the rare ability to decide whether those ancient relationships continue into another age. The oldest truth carried through this journey is remarkably simple. Long before human beings reshaped landscapes, crossed oceans, or recorded history, something hunted our ancestors from the sky. That relationship endured across immense spans of time, appearing in different places, involving different eagle lineages, and touching separate branches of our evolutionary family. Its record survived against extraordinary odds, preserved not in a single discovery, but in many forms of evidence that eventually converged. It remained within the skull of a child whose wounds rested undisturbed for nearly 3 million years, until careful observation gave those marks their meaning. It endured in the scars left upon the bones of giant flightless birds, where the pattern of talons revealed a predator's unmistakable method of attack. It also lived within the memories of people who shared their homeland with an eagle powerful enough to earn a permanent place in tradition. They remembered its appearance, the places where it nested, the way it hunted, and the circumstances that demanded caution. Centuries later, anatomy, archaeology, paleontology, and those preserved accounts reached the same destination from different directions. Together, they restore a chapter of human history that was almost forgotten. They remind us that our ancestors were participants within nature long before they became its dominant force. Survival depended upon awareness, cooperation, and the accumulated experience passed from one generation to the next. Every successful escape became part of a longer story that continued through descendants who inherited both bodies and behaviors shaped by those distant environments. Modern life rarely asks us to look upward with the same urgency. Cities, shelter, technology, and transformed ecosystems have changed the conditions under which our species lives. In most places, the open sky no longer carries the practical danger it once did. A passing shadow is usually nothing more than a cloud, a bird, or an aircraft moving overhead. The daily reality that surrounded our distant ancestors has largely disappeared from ordinary experience. Even so, the deeper history has not vanished. Fossils preserve it with remarkable fidelity. Archaeological sites preserve it through the traces of lives once lived. Carefully maintained oral traditions preserve it through memory carried across generations. Scientific research continues to unite those fragments into a broader picture of where we came from and how our lineage endured across changing worlds. Perhaps the greatest lesson is not that humanity was once vulnerable. It is that vulnerability occupied the longest chapter of our existence. Before we altered ecosystems, we adapted to them. Before we stood at the top of every food web, we survived within them. That perspective does not diminish humanity, it enlarges it, revealing that our story began with endurance before it became one of influence. The sky above us has changed very little across those millions of years. What has changed is our place beneath it, yet the evidence remains, patiently preserved in stone, bone, landscape, and memory, waiting to remind us that the earliest pages of human history were written by a world in which looking upward was often one of the wisest things an ancestor could do.